Welcome back, everyone. Today, we're taking a fascinating journey in this explainer to really demystify the hierarchical structure of the atom. We're going to break down the exact blueprint of how atoms are organized, and by the end of this, a topic that usually feels, well, pretty abstract is going to make complete logical sense. We're essentially visualizing the invisible here.
Okay, let's dive right in. We all know atoms have protons, neutrons, and electrons, right? But here is the fundamental question we're tackling today. Where exactly do electrons live inside an atom? Because they don't just float around randomly in some chaotic cloud. No, they have incredibly specific addresses. It's almost like a cosmic zip code. So let's find out how to locate them.
Here is our step-by-step roadmap for the day. First, we'll look at the anatomy of an atom. Second, we'll break down shells, subshells, and orbitals. Third, counting electrons. Fourth, the Aufbau principle. And finally, the electronic configuration sequence.
All right, part 1, anatomy of an atom.
Let's define our first major structure, and that's the shell. You might also know this as the principal quantum number, which we usually just represent with the letter N. So picture this. In the dead center of the atom, you've got the nucleus, packed tight with protons and neutrons. But the electrons, they're hanging out in these main energy levels, revolving around the outside. Think of them kind of like the main concentric rings on a dartboard. Now, scientists actually have very specific names for these outer rings, and our source material gives us a genuinely hilarious way to remember them. The absolute outermost shell is called the ultimate shell. Think of this like, your ultimate goal in life. Now, the shell just inside that is the N-1 shell, and that's called the penultimate shell. Imagine someone poking a pen into your ultimate goal. And who exactly is doing that poking? Well, it's the neighborhood anti, which perfectly represents the N-2 shell, the anti-penultimate shell. Ultimate, penultimate, anti-penultimate. Honestly, it's a brilliant little mnemonic to remember the hierarchy of these outer layers.
Moving right along to section 2, shells, subshells, and orbitals.
Now, to prevent total cognitive overload here, I want you to think of an atom like a set of nested Russian dolls. It's all about the relationship between these specific layers. You open the atom, and inside you find the shell. Open the shell, and you find the subshell. Open that subshell, and boom, you find the orbital. And right inside that orbital is where the electron actually rests. It's this perfect nested hierarchy. So what exactly is a subshell? Basically, these are specific pathways within a larger shell, and they're designated by the letters S, P, D, and F, and the math connecting them is beautifully simple. The shell number tells you exactly how many subshells it has. That's it. Shell 1 has 1 subshell, the S. Shell 2 has 2, S and P. Shell 3 has S, P, and D, and Shell 4 gets all 4 of them, S, P, D, and F. And then, zooming into the final Russian doll, we have the orbital. This is the exact, specific box within a subshell where an electron actually lives. Our source notes the Pauli exclusion principle here. So think of an orbital like a really small bedroom. The absolute strict rule is that a maximum of 2 people, or 2 electrons, can sleep in one room. No more than 2 electrons per box, ever.
Which brings us to part 3, counting the electrons.
Take a look at the progression of orbitals across our subshells here. It goes 1, 3, 5, 7. Notice anything? It's literally just the odd numbers. And since we just established that only 2 electrons can fit in a single orbital box, all you do is simply double the number of orbitals to find your maximum electron capacity. So 1 becomes 2, 3 becomes 6, 5 becomes 10, and 7 becomes 14. It is so perfectly systematic. Once you see the pattern, you can't unsee it.
All right, section 4, the Aufbau principle.
First off, and I think this is pretty funny, Aufbau is actually not a scientist's name. It's a German word, and it roughly translates to building up. This principle basically dictates the exact order of construction for an atom. It tells us that electrons are, well, they're kind of lazy. They must always fill the subshells with the absolute lowest energy first, before they even think about moving up to the higher energy pathways.
To help memorize this lowest to highest energy sequence, our source provides a really catchy chant. And seriously, I want you to literally say this out loud with me wherever you're listening from right now. It goes like this: SSP, SSP, SDP, SDP, SFDP, SFDP. Come on, let's do it one more time. SSP, SSP, SDP, SDP, SFDP, SFDP. If you lock that rhythm into your head, the whole order of electron filling becomes a total breeze.
Now notice how we attach the actual shell numbers to those letters in our chant. We use 3 really simple subtraction rules. For the S and P subshells, you just use the main shell number, N, super easy. But when you encounter a D subshell, you have to use 1 number less, so N minus 1. And when you hit that massive F subshell, you drop down 2 numbers, N minus 2. This neat little trick perfectly accounts for the complex energy overlaps we start seeing in larger atoms.
And finally, Section 5, Electronic Configuration Sequence. If we trace the exact chronological path an electron takes, applying our chant and those math rules we just covered, it maps out perfectly. So first the S, 1s, then the SP, 2s, 2p, then the next SP, 3s, 3p, then we hit SDP. Now, for the 4th level, the S and P are a 4, but remember our rule, the D drops down 1, so it becomes 4s, 3d, 4p. And the next SDP becomes 5s, 4d, 5p. Do you see how naturally that logic flows?
Let's put this into practice with a real boss-level challenge. 54, that is the atomic number for xenon, a noble gas. This means we literally have 54 electrons that need a home. So let's use our blueprint to place all 54 of them, making sure we fill up those lowest energy rooms first.
And here is the masterpiece, the fully completed xenon configuration. We start filling. 1s takes 2, 2s takes 2, 2p takes 6. Boom, that's 10 electrons down. We just keep following our chant. 3s takes 2, 3p takes 6. Then 4s takes 2, 3d drops in and takes 10, then 4p takes 6. Now we're up to 36 electrons. We keep pushing right into the next SDP phase. 5s takes 2, 4d takes another 10, and finally 5p takes the last 6. If you add up all those little superscript numbers, they perfectly equal 54. The building up rules completely solved the puzzle, and we didn't have to blindly memorize some massive string of numbers.
So, you've successfully unlocked the hierarchy of the atom, from those outer ultimate shells all the way down to the tiny orbital boxes. You understand the exact mathematical capacity of every subshell, and you know the energy chant that dictates where the electrons go. Now that you hold this cosmic blueprint in your hands, what element's configuration are you going to build first? Pick a number on the periodic table and test your new skills. Thanks so much for joining me on this explainer, and keep exploring.